here's a key question, and I don't know if Say and Zach can turn on their videos again, because this is going to be the audience participation situation portion of the program. And you should also, unless you have ambient noise in background, I don't know, Say, if your fan is making noise, I'm not sure. But if you don't have ambient noise in background, you can unmute, because I'm going to be asking you a whole bunch of questions now. And this is the audience participation situation part, okay? So everybody go ahead and unmute. Now, Ilani, you can unmute your microphone unless you have background noise. So the way to ask this, let me start this way. How many of you have background in designing microgravity experiments? Raise your hands. How many have background? Okay, well, that's kind of scary, right? I have no idea what a microgravity experiment is, so how am I going to get my students to design microgravity experiments? Because that's your job. Your job is to get your students to design microgravity experiments. Your job is to give them everything they need to know so they say, I know how to do this, and they go and do it. So I think what I need to do in the context of this training program is to give you a very good, solid understanding of what a microgravity experiment is, so that you say, I got it, right? I have to demystify it. And the best way to do that is to start with a description of classic experiment design, because I'm going to show you that microgravity experiment design is a slam dunk, easy outgrowth of classic experiment design. And I suspect many of you have heard about classic experiment design over if you're an instructor, you obviously teach this. If you're a student facilitator, I'm sure you've experienced this in prior science classes. So I'm going to start with that. So let me kind of explain what goes on here. An explorer, whether it's a professional researcher on the frontier or any of you, anybody, has to start with the gift of a question. So the way to think about it is that we are all born curious. We're all born to ask questions. We're all born to do that. And if you don't believe me, if you go to your mom or your dad and you say, Mom and Dad, when I was first capable of talking, did I ask questions? And your mom and dad will say something like, yeah, you asked lots of questions. That's when the unending stream of questions began. We are born to ask lots and lots of questions. And so the whole idea is that you open yourself up to curiosity, you look around your world, you see something interesting, and you dare to ask a question like what or why or how. Something excites you and you dare to ask the gift of a question. Why is it a gift to ask a question? Because if you don't know something, you can ask a question and it starts a personal journey. Or more formally, when you ask a question, it defines a problem to be solved. And we can call the question that you asked to define that problem to be solved the essential question. So I look around my world and I see something biological, chemical, or physical. And I want to ask a question of something like that. So let me give you an example. Let's say I want to understand how these seeds germinate. Is it enough for me to have seeds to do that?
Nope.
What else do I need? Okay, let me tell you how this game is played, okay? There are no wrong answers. I'm going to ask leading questions because I'm kind of modeling best teaching practices here. I want to get you all thinking. I want to get out of lecture mode. I want you to help tell this story so we all have a sense of ownership in this story. And the other thing that's important is don't think about it. Just respond to my question with regard to what's top of mind, because we have to keep this moving along. So if I want to study how these seeds germinate, is it enough to have the seeds? Justin said no. What else do I need?
Soil.
Soil.
And it depends, like, are you having like more parts of the experiment or just the seeds?
Well, I'm trying to see how these seeds germinate. So you're telling me I can't just do the seeds. I need a growth medium. That's a good answer. What else do I need?
Probably some pre-existing understanding of at least an analogous real-world situation. So a certain level of content knowledge to inform a testable, replicable procedure.
Okay, so you're looking at that the background knowledge that I need, but just from a physical standpoint, what else do I need for those germinating seeds? I'll give you an example. Do we need water?
Yep.
Yeah.
Yeah, give me some more.
Sunlight, energy source,
Sun.
or some type of energy source.
So once it germinates, if I wanted to continue to grow, I'll need light with a certain frequency distribution, a certain amplitude distribution, in other words, a spectrum. I will probably need an atmosphere with a certain composition. I'll probably need a temperature. And so what you can see is that I can't just study the germinating seeds by themselves. They have to be studied in an environment with a whole bunch of characteristics, thousands of characteristics. Just the composition of the soil could be 1,000 different characteristics in terms of what makes it up. And so no matter what I study, whether it's physical, chemical, or biological, will it be studied in an environment?
Yeah,
Yeah.
for sure.
Yes. And will that environment have a series of characteristics?
Yes.
Yes. And so as soon as we understand whatever we're studying is going to be studied in an environment, we add the word system to it. So we're studying a biological system, a physical system, or a chemical system. Now, can somebody give me a more sciencey word to replace the word characteristics, which is very generic? What's a good sciencey word for all of
Variables.
those characters? So what did you say, Justin?
Well, I still would say set variables.
Variables, very good. And so why do we call them variables?
Because they can be changed.
They can be changed. And Ilani, why would you want to change them?
I guess depending on your experiment, if you're testing for certain things, you want to observe the changes so you can make conclusions.
So I think what you're saying, which is really good, is if I change the variables, I can see a behavioral change in what I'm studying, so I can understand the role of these variables on what I'm studying. Is that what you were saying?
Yep.
Let me say it again. If I change variables, I can see what the change in the variables does to the behavior of what I'm studying to get a better understanding of how this thing I'm studying works. I want to understand the role of the variables on what I'm studying. Is everybody with me on that? Does that all make sense? Okay. Do we change all the variables at once?
No,
Why?
because then you're not going to get an accurate experiment because you're looking at multiple factors influencing the dependent variable.
Okay, so what Say is saying is if I change all the variables at once and I see a behavioral change in what I'm looking at, I have no idea what variable is causing it, right? Is that correct?
Yeah.
Yes.
So can somebody tell me what we do in classic experiment design?
Try and keep all variables but one or maybe two controlled and steady, and then look at gradations of the independent variable.
Okay, so let's unpack what Justin just said. What he's saying is in classic experiment design, you try to keep all the variables constant if you can, except one. And that one is called the independent variable, and you change that one and you see what happens in what you're studying. You're trying to understand the role of that specific variable in what you're studying. Is everybody with me on that? With me and Justin on that? Okay. Now here's the really deep question that in science class we don't often address. Okay. There could be thousands, 10,000 variables in an environment, but we only want to change one. Of all the variables that are in that environment, how do we figure out which is the one we want to change? How do we figure out which is the independent variable? Deep question. I'm going to take a sip of coffee while the Jeopardy music plays and you're thinking.
I think a lot of times it depends on
Anybody have any ideas?
A lot of times it actually depends on what we have the resources to measure, right? We may want to study lots of things, but if we can't consistently garner access to um, and measure the independent variable, we're actually not going to be able to do the experiment. So
But it
hopefully,
may,
based upon a gap in the field, we can see what might be a high likelihood to have, some influence on the situation, and then if we can garner the resources and measurementation and instrumentation, then we can execute an experiment.
okay, so let me play devil's advocate. Let's say all of these variables are hard to control, right? But this one's easy. So, okay, let's go with this one because this is the easy variable to make the independent variable and change. But what happens if the independent variable that's easy to change has nothing to do with the experiment you want to conduct?
Hopefully, your statistical analysis will show that you didn't reach a threshold of significance.
Okay, well, that's true, but it seems to me that it's kind of a brute force approach. If you've got thousands upon thousands upon thousands of variables in an environment and you want to pick one, there's got to be a better way to, instead of going, let's do this one, let's do that one, let's do the other one. There must be a better way to zero in instantly on the variable you want to change. Instantly. Otherwise, the experiment is not well defined. So there is an answer to this. Can anybody think about how we figure out which is the variable we want to change? That's really important. Where did it start?
In the literature,
Actually, it started a little, it could have started in a literature search that got you interested, but where did this particular journey start?
in your curiosity.
Well, the curiosity is everywhere, right? You open yourself up to the curiosity, but what did you do in the face of that curiosity to start your journey? Anybody? You asked the gift of a question. It all started with a question. Your curiosity, well, you were open to it. You looked around your world, you said, wow, that's really interesting. And you dared to ask the gift of a question. Why or what or how? And that defined the problem to be solved. And that screams to you what the independent variable needs to be, because the essential question defined the problem to be solved. Forget all the other variables. It's telling you where to go. Does everybody understand how this connects to the original essential question? Now, what you may do with that essential question is come up with what you think might happen. We call that a hypothesis. But sometimes when you put forward a hypothesis, you are biasing your thinking because you're thinking about what will happen, as opposed to just poking the world and seeing what happens. So often in science, a hypothesis is not done. It's not used. Why bias yourself from the very get-go? We often teach the scientific method as a rigid recipe for success. Hypothesize, observe, conclude. That's not the way science works. Science is an art form. It's very personal. It's a process that's very personal to the researcher. And sometimes you don't even want to put forward a hypothesis, but it all starts with a question. So does everybody understand where I'm coming from with this? I'm trying to give you the logic flow for classic experiment design. So does anybody have any questions about classic experiment design? Let me kind of summarize really fast. You open yourself up to curiosity. You look at something interesting. It could be physical, chemical, or biological. You ask a question. It defines a problem to be solved. I gave you an example of germinating seeds. I said, do we need anything else besides the seeds? You helped me backfill. We need an environment with a lot of characteristics. And I said, is it true no matter what I study, whether it's physical, chemical, or biological, it will be studied in an environment? And you said yes. And I said, does that mean that every environment will have a series of characteristics? And you said yes. And then I said, well, that's when you add the word system to it. You're studying a physical, chemical, or biological system. And then I said, well, can we name the word characteristics with something more sciencey? And Justin said variables. And I said, why variables? And Ilani said, because you can change them. And then I said, well, why do you want to change them? And we concluded together that if you change all the variables, that you want to change it because you want to understand the role of the variable in what you're studying. And I said, do you want to change all the variables at once? And there was a collective no. And I said, why? And then Say said, because we won't know what variable caused the change that we are observing. So Justin said, let's keep all the variables constant except one. We call it the independent variable, and we see what happens. And then I said, well, where did the independent variable come from? And I led you to, it was the original question that you asked. That's where the independent variable came from. So everybody with me on that so far with regard to classic experiment design? Okay, so now let's go to the next level. Let me give you an example. The Acme Seed Company says, we have genetically engineered a species of wheat that grows really well in dry climates, which means we can bring food production to areas of the earth that see famine. Well, that's all well and good. I'm listening to what they're saying, and it sounds really cool because if they can bring food production to areas of earth that normally see famine, that's a huge thing. But how do I know that their sales and marketing people are just not saying that? I mean, just saying this, that there's no evidence for what they're saying. I want to know, is their claim correct? Is it accurate? So if I want to test their claim, I'm going to turn their claim into an essential question by adding question mark. Does this genetically engineered species of wheat grow really well in dry climates? That's my essential question. Can somebody tell me what the independent variable needs to be?
Climate dryness.
Climate dryness, which is another way of saying
Humidity.
the amount of water, right? I want to understand the amount of water. How I want to change the amount of water and see how food production varies with water. Well, let me put a graph up on the screen here. You ready? This vertical axis is food production. This horizontal axis is the amount of water. So what I'm going to do is I'm going to measure the amount of food production as a function of water. So we use a little water, then a little more, then a little more, and more and more and more. And I graph food production as a function of water. Now, here's the hard part. What I want to show is that in the low water regime, in the area of the graph where I'm only providing little water, I get better food production. Right? I get good food production. Good food production relative to what? I want to show that with less water, I get better food production. What does that mean? Better food production relative to what?
Relative to the ungenetically modified plants.
Oh, say that if I had more jelly beans, I would throw you some virtual jelly beans. Exactly. You have to compare it to known wheat. Right? The genetically engineered species of wheat is a new life form. It's never existed on the planet before. So if I want to know if I get better food production with less water, it has to be better relative to regular wheat that may have been used for thousands of years. So if I make the same plot with regular wheat, food production as an amount of water, what I want to show is in the low water regime, I get more food production with the genetically engineered species of wheat than I do with regular wheat. Let me say it again. I'm looking at how food production varies with the amount of water for the genetically engineered species of wheat and the regular wheat. And what I want to show by comparing those two experiments is that for low water levels, I get higher food production with the genetically engineered species of wheat than I get with regular wheat. Does everybody understand that comparison and why we make it?
For sure.
Okay. Does anybody want to tell me, say, you came up with this, say, what do we call the experiment with the regular wheat, the known wheat?
Your control.
The control experiment. So now we're adding another level to classic experiment design. We often need a control experiment of something known to compare to the unknown so we can see how behavior is different. Okay, so everybody understand the whole idea behind classic experiment design?
Yes.
We're good? Okay. Any questions about classic experiment design before I move on to microgravity experiment design?